Hello, everyone. We'll just get started shortly, so hang in there and welcome. Okay, I think we can go ahead and get started. So thank you, everyone, for joining. My name is Kritika Kharbanda. I'll be the moderator for this session. And we have Kjell Anderson, the Director of Sustainable Design at LMN Architects, who will be talking to us about what's your lead and specific focus on storytelling in building performance. But before we head to that, I really want to thank our sponsor for this webinar, A2 Efficiency. And we have Neil Ulger joining us, who's the founder and principal at A2 Efficiency. So over to you, Neil, to give us a spiel on what A2 Efficiency does.
Yeah, thanks so much for the introduction there. I'm really excited to sponsor this little event. A longtime enthusiast of Project Stasio and IBPSA and what we're doing here. So yeah, A2 Efficiency, we're a small but mighty consulting firm. Been around for a couple of years, but we kind of bring together building science and engineering practice and work in the same space of storytelling with energy models. From everything from design practice to helping codes and really bring some of these ideas that drive highly sustainable designs into common practice in codes and standards. So I say we're like professional translators in a lot of ways. But yeah, really excited to be here. But yeah, this is generically, we get a little bit involved in ASHRAE, a little bit in all those other things. But we spend our time, between design consulting, research, and then technologies, what really makes a technology work. But again, this whole space of, it's all about the story, right? Like if you can convince people about what is in their benefit and what's in the larger benefit, it really makes it work. So glad to be here, but yeah. Thanks.
And I see you're hiring, Neil. We do have a lot of students who join.
Yes.
So
yeah, check out the website. Happy to talk to people again.
Wonderful.
Trying to
Thank you so much. And I also want to point out that this webinar qualifies for the AIA credit. If you've provided your ID number during registration, it should be assigned to you automatically. But if not, please email it to admin@ibpsa.us, so the email that you see on the screen, or you can contact us afterwards with any question, but if you want to go for the credit. And very briefly, I wanted to give a spiel on what Project Stasio is. This is a group which is basically working on it's an offset of the IBPSA, which is International Building Physics Simulations Association. We are a group of architects, researchers, sustainability consultants, simulation experts who really got together to answer this one question: that why are we running these studies? Very often we have people in our companies come to us and say, hey, let's do a radiation study, or let's run an energy model. But for us, we really think that questions matter much more than the tools or just running a simulation for no rhyme or reason. So the whole premise of why this group was formed was helping our teams understand how to frame questions better to provide useful answers. So rather than saying, hey, let's do the simulation, what we aim to do is take an approach which is, hey, let's study what is the impact of, let's say, exterior shading on comfort or on peak cooling or carbon emissions. So really driving these decisions, driving these tools, these studies by a core question that aims to answer a particular solution. We've been around for a while, and the main idea of this group, all of our efforts, is how to best communicate the results to these questions. We do webinars. We also have an annual awards, is it called an awards or like a competition where you as students or even professionals can submit their entries, and we have a stellar group of judges. And at the end of this webinar, I'll also announce the next session that we have, so you can keep an eye on for that. We have an online repository, so you can really filter through what kind of project typology is it, what is the location, and what is the question that we are trying to ask. And it's a great resource for early professionals and students who are trying to just get into this field. And I just want to make a plug. We are looking for a website master. So if you are someone who's interested in helping us out, you can see a snapshot of team. Kjell was a founder, so it's great to have you back, Kjell. Please email us on the email address that you see here. And without further ado, I don't want to take more time, but I'll do a quick intro for you, Kjell. And this is like by no means restrictive. You're way more than what I have right now here for you. But Kjell is an author and an architect practicing as the Director of Sustainable Design at LMN Architects. Beyond working on projects, he is an inaugural member of the AIA National Energy Leadership Group, served as the AIA Washington Political Director from 2011 to 2014, and was an AIA Seattle YAF co-chair. After starting an architect-based energy modeling program in 2010, he has keynoted the ASHRAE IBPSA Simbuild Conference in 2016, and also spoken at the AIA Convention, Greenbuild, and other conferences. He also wrote a book, come on, are you kidding me, on energy simulation entitled Design Energy Simulation for Architects, that is used at several universities. In 2016, LMN Architects won the AIA National Firm Award, while Kjell won the AIA Seattle Young Architect Award. We are so honored to have you back, Kjell, and I'm super excited to dive into it. So the stage is yours. Thank you.
Thank you, Kritika. That makes me blush, so I'm a little bit red right now. Yeah, it's great to be back. It's great to see that Project Stasio has had a long life after I got busy with other things, and handed it off to lots and lots of other people. I still go back and look at it for graphics and ideas on how to present energy simulation and embodied carbon simulation as well, which is something I've gotten more into since 2017. So I'm Kjell Anderson. I've done all those things, and I'm also on the Building Code Council for the state of Washington, so I get to help write our energy codes and work with lots of people on that. And that's a pretty exciting thing to have that kind of influence and ability to work with utterly brilliant people. So I work at LMN Architects. We do a lot of projects as the historic renovation and addition of the Seattle Asian Art Museum, the Vancouver Convention Center with this huge green roof in the left that kind of blends the landscape with this. This is a LEED Platinum project for new buildings and existing buildings as well. This is another renovation, the San Antonio Center for the Performing Arts, Tobin Center, where we had to insert a new performing arts center inside a historic building. This is a more recent project where we did mass timber on it, and it's beautiful, but it also has a bunch of stats to show that it was done well. This was our first project that used ASHRAE 209 as an energy modeling set of parameters, where we put that in the RFP for mechanical and energy modeling services. This is an utterly brilliant project in terms of its performance. It actually used an outcome-based energy modeling or energy code compliance path. So its proven energy performance is about what it was modeled at as well. So we had a great team on that. And I get into this because these are the happy statistics that happen when a project is done and open. But all the stuff that happens early in the project is what allows us to happen in the early energy modeling at the earliest stages where we were even massing the building. We put the naturally ventilated office bar on the northeast so that the sun wouldn't overheat it. And we put the areas where we knew mechanical conditioning was required on the south and west, so that because we knew there'd be mechanical conditioning in there. If you remember one thing, it's that so I go to the IBPSA conference from time to time, and I go to the ASHRAE conference from time, or the Simbuild from time to time, and I see this every time, and I'm like, please get your graphics better. Someone will have worked for a year on this simulation results, and they present it in a way where nobody understands what they're talking about. So remember one thing, write an executive summary, then summarize that executive summary into a single sentence and create one graphic that illustrates the sentence. And that's just simple, simple, simple. And then during a presentation, you make a generally true statement, because I hear people get into nuances before they get into the conclusion. Say the conclusion, then pause, let it sink in, and then get into nuances. So this is what an architect sees when they're looking at an energy modeling report. They are a pilot that are trying to design a plane, but they've never been, trying to steer a plane, but they've actually never steered the level of detail that you all are presenting to them. And they're trying to figure out, well, what's important? Here, there is no graphic hierarchy. There's stuff in the center, but there's a lot of stuff in the center. There are things on the right and the left. There's buttons, there's dials. This is what they see. Okay, so I'm going to spend 10 seconds on this, trying to figure out what this means. Okay, so what conclusions did you draw from that slide? That's kind of what an architect sees when they see an energy modeling results. Okay, there were no labels, or there were only acronym labels. There was no title, there was no conclusion. So, okay, let's add some text to this. All right, you have 10 seconds to figure out what this means and what conclusion you should draw from it. Someone put a lot of time into this, but that doesn't mean that anyone else can understand what it says. Okay, so did you draw any additional conclusions as you looked at that? Do you think perhaps now you know the solution to a certain question you may have had or something like that? Okay, now you have 10 seconds, and you'll notice I added a $2.5 million sum on here. And that's probably what you see when you look at this, and you're like, I don't know what ATP is, I don't know what mito respiration is, but I know what $2.5 million is. So when you draw a conclusion from a chart, the biggest, boldest number or thing that you understand is what you're going to draw from that. That's what you look at first. As architects, we're very visual, and in the study of visual arts, what you find is humans tend to be drawn to certain things first, second, third, fourth, fifth, etc. And you can use that to your advantage when you come up with a slide. Most energy modeling simulation results slides look like a Rorschach test where you just don't know what you're looking at. You just make up what you think you're looking at. And not to pick on this program, but like, what is this? It's really, really hard to tell what that is. And I've looked at it a bunch and I still can barely interpret the results. Or this, never show an architect this kind of stuff because it's not going to get through to them. Or this, like, all right, we did 6 strategies. We did it to a high level of detail, but the number change in here is so subtle that it's hard to tell what conclusions you're suggesting could be drawn from this, or if any conclusions could be drawn from this. And this is the summary table. This is the first thing that an architect is going to see when they look at it and try and make sense of it. Okay, this is one of the winners from Project Stasio. It says, all right, what's the impact of context in terms of shading? All right, you can kind of see that this bottom thing is more shaded in the morning and the afternoon. It's a good use of color and a good use of a simple question and answer, as Kritika was mentioning earlier. This is another thing that I see. So this is the building, and we're looking at which has the best shading. And of course, the answer is they have the same amount of shading. I just played with the scale to mess with people. So the scales should be chosen to illustrate a point and not necessarily from 0 to the maximum number. They should be done to illustrate a point, such as the top one looks like everything's well shaded, but in reality, a lot of stuff's not well shaded in the top one. The bottom one is more indicative of what is being shaded throughout the year. And there's even better versions of this where you talk about the percentage of the time shaded in the year or temperatures outside when the shading is occurring. And feel free to ask questions. If anyone's read The Little Prince, there's some good stuff about the book. And it has to do with removing things from graphics. We want, as technical people, we want to include all the stuff, but you can't include all the stuff and have people understand it. There's progressive graphs where you do something simple and then you add stuff to it, and that's a fine way of doing it. But someone should be able to figure out within 10 seconds what your graph is about without you explaining what it's about. That means titles, line weight, all these things. And these things can be done fairly easily without sophisticated software. So first, use charts and graphics to tell your story. Instead of dumping stuff into a report and writing about it, think about what's first in the report, what's second in the report, what do you want the conclusions and the nuances to be. Number two, titles should be thought through. Titles should describe the intent. What are you doing? What question is the graphic answering? And I like questions because people respond to questions very differently than they respond to statements. While text should be readable, I go to so many presentations where the important conclusions are in small text somewhere on a graphic and nobody can read them, or the legend is in small text on a graphic. There's hierarchies of titles, legends, and labels, big to medium to small, and I'm going to get into that in a little bit. No industry acronyms. If you want someone to understand something, you spell it out, and maybe if you're going to use it 20 times, maybe the title needs to include that with parenthetically the acronym, just so that people understand it. And then extraneous information. You don't need to do this, but I end up recreating all the Excel graphics in some other software or modifying them some way, because that's how I can get it to be clear to architects and especially our clients. Because a lot of the graphics you come up with, you are not going to present them to the ultimate decision maker. You're going to present them to the architect. The architect is then going to have to present them, not knowing what they're about, to the client to actually make decisions on them. So how few words can you use? Can you summarize it in 8 words? Titles shouldn't be more than 8 words unless they're a Salvador Dali painting or something like that, where you're really going for length. Another big one, stand 5 feet back from your computer. What do you see first? It's actually really a good exercise you need to do from time to time. Just get way back there and look at what is the thing that you see first, and what is the thing you see next? Can you read it from 5 feet back? Because a lot of people, and especially when you go to conferences, are not sitting as close to the screen as you are to your computer when you create that. So the number 3 is, of course, slightly less important things, but it's good to have baseline or normalizing information so that if someone has to represent it, they know what your baseline information is. Colors are really useful as long as they're used intentionally to differentiate something from something else. If you're presenting a bunch of graphics that have a scale on them, ideally the scale is the same among the graphics, so that if you have a false color diagram, all of them can be seen in the same false color scale. And you're supposed to understand your end user's knowledge level, which means right to visually centric architects that will have a short attention span and want to see images. When I read books, I'll be honest, I look at the pictures and the captions first. And then if I like the pictures and the captions, I think they're intriguing, I will read the text. And I'm a more techie architect than many. Okay, so just 4 basic things of hierarchy. People read left to right, they read top to bottom, they read big to small, and they read bold and colors first. So think about what you saw first when you looked at this graphic. Intentionally, I have the 1, 2, 3, and 4 in large letters so that you'll see that there is an order in which you're supposed to read these things. And then I place the graphics in the center of the screen so that you will kind of focus on those. And then I, of course, arrange them in a certain way to illustrate the point. Okay, so you work for months and months to get certain data, and you come up with this pie chart that summarizes everything. And this is what you want to present. And this is the end all be all of something. And you title it Acronym Salad because that's what it is. And you present this pie chart, and someone is supposed to understand what it means. And so they think about what problems you would have in understanding this pie chart based on what I've said. And if we were live, I would ask for someone to pipe in on that. But if you all think about it, okay, one big thing, the titles were in a legend. This is going backwards. Right now, I have to look at the color. I have to see, is that blue the same blue as the other blue? I don't know. And there's two greens in there. Which green is which green? I don't know. So labels on there. Okay. The other thing is we read left to right. What do you read first? You read category, other, not important, information. You read that stuff. And the most important thing is in thing 1 and thing 2. So why not take all the other stuff, put it into a category? You know, I see this all the time with certain, you know, like ventilation loads or pump loads or something like that, that are like 0.5% of the energy use, and yet they're in the upper left, meaning that's what you read first, and you think, well, it's obviously it's obviously about the pump loads because that's in the upper left. That's what the person's telling me visually. So you put all the other stuff in a category and you title it something like all the other stuff. And then all of a sudden it's like, all right, now I realize it's about thing 1 and thing 2. Well, the thing is, you can also rotate the pie chart, and you do this in Excel really easily. I did all this in a couple minutes. So now the first thing you read in the upper and the left is thing 1. Then you read thing 2. And then all the other things you don't really need. So this is, you know, 30 seconds of Excel, and now you've made a much better pie chart. You also need a better title. So you have acronym salad. Now you decide focus on things 1 and things 2. And ideally, a title tells you the conclusion you're supposed to draw or prompts you to the conclusion you're supposed to draw. If this pie chart's goal is to say, well, what is the most important thing in the energy use or the embodied carbon of my building? This title will tell you, well, it's these two things, thing 1 and thing 2. Now, if you were doing a pie chart that said, we have no control over thing 1 or thing 2, and we really need to focus on all the other stuff, you could design a different pie chart if that is what you were trying to do. And pie charts are not the only thing you can do. This is maybe even a clearer way to say, let's focus on thing 1 and thing 2. You're rating them left to right, and you can see the size just like you can with a pie chart. So this is called a tree map. This is available in Excel. You probably used this before. And so LMN did a series called the Path to Zero Carbon series, and you can Google that. And it's a 16-part long-form blog on all things carbon. And I've sent the PDFs of it to like 50 people, so you can email me and I'll send you all the PDFs of it. It's free, it's online. We had lots and lots of people help us write it and review it, and it's graphically forward. So some of the graphics I'm going to show you are from that. This is an example of an embodied carbon of an office building, you know, using basically the same thing. You want to read left to right, and you want, you know, colors to be differentiated. We put a percentage in here so that you could get a little bit more detailed about it. So, you know, an example of a graphic where we spent a good deal of time on it trying to get it so that it would communicate what's important. And this is the kind of graphic where you might need to spend 20 seconds on it to really understand what it's about. And it's really about a hierarchy of embodied carbon. Here's another one from the title slide. We were trying to illustrate the point why our operational energy use at LMN is less important than the projects we design. So we put this circle diagram together to show how it was, the relative importance of it all. And we could have done a few things different, but you can see the title is LMN design impacts or 600 times our operational impacts. I've read everything I need to know, and now I can look at the graphic and understand the graphic, like why does this graphic look like this? This is a brilliant one that has been generated. It's freely available, and I forgot the website, but it's like global average temperature change. It's pretty clear that it's getting warmer, and some of the warmest years are more recently. This is another one. This is NBI did the original graphic here. We recreated it and added a couple things. And this is an example of a more complicated graphic where you're trying to illustrate a concept. So there's an upper row and a lower row, and then a left column and a right column. And So we've got a title that says with and without grid integration. So we're trying to get at the nuance of this. And then we used 3 colors, and they're consistent throughout here. We provided a few descriptions of what the colors mean, and the main conclusions, but we didn't include a lot of other information on this. So this is an example of a graphic that we're actually missing a bit of text there in the upper right. Here's another one. It's embodied carbon globally, and it's a way of highlighting a subset of a subset using, clear pie charts. So what did we use? We used progression from left to right. Here's global on the left and manufacturing breakdown on the right. We used a consistent color. So everything else is faded back in gray, except for the one that we're focused on, manufacturing, that's capitalized and bolded. We have just a little bit of information on each of the pie charts. So this is an example of another one where it's trying to communicate a lot of information as succinctly as possible. Here's another one, annual refrigerant leakage. What you want, what we're going for this one is, well, what do we need to worry about and what do we not need to worry about? Supermarket refrigeration is clearly the biggest one. It's the first thing you're going to see on here. It's both to the left, to the top, and the biggest circle. Commercial condensing units is another one, also in the top, also kind of large. So just examples of graphics that you can be used. Here's another one that's more of an energy simulation. And this is trying to convince an architect that your glazing is your most important thing. So when you look at peak cooling and peak heating, you can see that the most important ones are solar radiation, glazing, conduction, and filtration. And those are all about the envelope and the glazing. And you can see I put other losses and other gains in a much lighter color in the bottom. So ventilation is really important, but because it's a lighter color, you focus on the top. I also circled the top one to make it clear that that's really important. What should our target EUI be? Another one where it's a bin chart, and I like bin charts because you can kind of see where the median is, and then you can see about where, and I like the color fade here, left to right, where you get a sense of, all right, where should we set our targets in here? And there are some projects better than this, some projects worse than this, but where, and you can, I think the average person could look at this and say, all right, I should be between 50 and 99 for an Energy Star score, and that means my EUI should be, I don't know, somewhere between 130 and 230 or something like that. So it's another good example of a graphic. There's another one about embodied carbon, and this is a concentric pie chart, and we're trying to illustrate here that there are reasons and sub-reasons. So look at what you see. First, we wanted to show that 68% of the surplus materials for embodied carbon are due to procurement. And then you can see the breakdown of those. 39% is installation, 21% is estimation. So we broke this more complicated pie chart into 3 subregions so that you can see how that's done. And this is all about telling a story. As was mentioned earlier, questions are how we approach all energy simulation. And why does it start with questions? Because someone will say, run an energy model or do a daylighting simulation. And in fact, that's not a question. And that shows very little investment on the design team and what the answer might be. And all energy simulations that I've come across have areas where they're highly accurate and areas where they're less accurate. And when you're answering a specific question, you can make sure that the highly accurate portion is answering the question, and the less accurate portion is used for other things. An example of that is if you're saying, well, what amount of shading do I need on my west facade in order to minimize peak loads? you can design a simulation that will be accurate in terms of that. How many CFM am I reducing to minimize peak cooling loads? Whereas if you ask a different question, which is, how do I prevent glare from the west facade? You might run a very different kind of simulation. So, and then there's kind of understanding questions, which are for basic things, and those are okay. But design questions are the ones we're going for as architects, because those will actually impact the design. What do we have control over lots of things. So how do we improve those things? But we also have very little control over some things, and we don't want to ask questions about things we have no control over, because that just wastes your time and our time. Okay, so poll time. So how do you see in your typical interactions with a design team, is this number 3, where you meet with the design team regularly and work with them on reports and have times to ask questions? Or you meet with the design team once, you deliver a report and you don't hear back? Or number 1, you were asked for a report, you don't even meet with the design team, and you deliver a report at the end and everybody's happy, but nothing is really changing about that. We strive for number 3 on here, and we get there on most projects, but it's not clear. So I'm going to move on, but please vote on this, and I will see. We'll see what happens. We often set up our contracts and ask our energy modeling friends to have fee in there to meet regularly, and we find in concept and schematic design it's really helpful. What we start out with is a series of internal questions that we ask about the project, where we are actually curious about something. Piquing curiosity is a good way to get people to do something. So we brainstorm questions, and what we found is that most questions that we ask internally can be answered with intuition based on the experience of the energy modeler and the mechanical consultant. And that's great because we don't have to pay a whole lot for that. A few of them we do have to do energy simulation on, and some of those are, well, let's do that now, let's do that in 3 months or something like that. The questions have to be actionable. In other words, they have to be about something we can change. There's no reason to talk about building orientation when your building entrance has to face a certain direction due to a street or a grid or when you have a view in a certain direction, you know you're going to have some glass facing that. There's no reason to talk about orientation and run a model that rotates the building around if you're doing that. Likewise, sometimes we as architects say we are going to do above code insulation and above code shading, and there's no reason to model code shading if we know we're going to use above code shading. Things should be project specific. I don't care about when I'm designing an individual project. I don't care about so much about, what the average end use energy pie is for the average hospital in the US. I want to know what the average hospital is in the region in which I'm designing, climate zone in which I'm designing. And ideally for the actual hospital I'm working on, the actual hospital I'm designing and the size of it and all the conditions of it. And questions should be wide-ranging. They should question things like we're working on a project now and it's got some fan power that we were trying to reduce, and so we talked about yesterday a question where it's like, well, what if you put in MERV 13 filters for the smoky season or the dusty season, and you put in MERV 8 for the rest of the year? That could reduce fan power, but how do you simulate that, and how do you make sure that would actually happen in there? But that would actually reduce functional fan power in operation. We can ask a wide variety of questions. We shouldn't limit ourselves to just what we know we can do. So rule 1 of brainstorming, there are no stupid brainstorming things to say. We just write it down and move on, and a lot of it can be answered quickly. And okay, we use a standard form for studies, and I say promises because often we will have, 5 inches of exterior insulation on a project in a more extreme climate. And that's good building science, but it's also good energy performance and reduces the total mechanical system size in many cases. So we put a bunch of glass types here. We put a bunch of different, where they are, we give you elevations with the different glazing types we want to study on those things. Maybe we want to study GL3 on these 2 facades, but we also want to study GL2 on those same facades. We give you the product specification and opaque wall amount of insulation we might put in there, floors and roofs, lighting, and any other ECMs. And we do this and we send it, get it back, send it, get it back, and we update it throughout the project so that our mechanical is able to actually design to the building that's being built. We got to the end of a project once, and the client said, we're going to get rid of the shading devices on the exterior of your building. And we said, client, but the mechanical took that into account, and you'd have to upsize the system. We got cost savings because we put the shading on the outside of the building. And the mechanical said, well, I anticipated that this would happen, and so we designed it as if there was no shading. And that was really frustrating for us, of course, because we had assumed that we were taking the cost savings from a smaller mechanical system due to the shading. And so that's not a good outcome. We want to be able to promise things to the mechanical that are true and in the cost and the budget and that kind of thing. This is an example of a simple energy simulation that we can do at a massing percentage. For instance, we can just guess that our classrooms are going to be about 20% glazed, between 10 and 30 or so. Offices might have 30 to 40%. Public areas probably are going to be, 50 to 100% glass. So this is a worst case scenario. So we put the program stacking together, which we do in a couple hours. We do maybe for a project. And then with this, we could actually see, based on the climate, how much sun was going to fall annually or during peak times on the amount of glazing on each of these, and multiply it by the amount of glass. So this is not a simulation. Results is a simulation type. It was able to, in the course of a couple days, get us answers about where, what massings were going to get us into trouble in terms of solar performance. This is another one where we were doing a naturally ventilated building in Seattle. And this is looking at, most of it faces north, but there's a south classroom. And then our MEP engineer, PAE at the time, or PAE, put together some graphics that showed us how the project would perform under current climate conditions, using an older TMY file because they're all older, a relatively current TMY-ish file, and then a future file as well. So we're able to see where issues would be and what we could do about them during the design process. And so the building was designed so that even in 2050, we can still use the natural ventilation. It should be comfortable. All right, getting towards the end of the presentation, what does a journalist do? And they're looking for the lead, they're looking for the headline. So I read a book and it really influenced, this one example influenced me, so I'm gonna test you with it. So a journalist teacher has all these journalism students in there, and they said, all right, I'm gonna give you an assignment. You have half an hour to write an article on this story. And the superintendent of the local school district said all the teachers are going to go take this training on advanced use of computers in the classroom next Thursday. And so all the students diligently write this story, and he gave them a bunch of more information on the type of training and what type of computers, and they wrote this. And they said, all right, turn in what you get. And he looked at it. And the headline that the newspaper would want to run would be, school canceled next Thursday. But nobody wrote about that because the prompt they had been given was the teachers were going to be trained on computers in a conference. So sometimes the headline is not the information you have, it's the conclusion you want people to draw out of it. And newspapers are really good at this. If you look at, this is just one example of an online newspaper, there is a headline, which is usually 8 words or less. Sometimes they're longer on this. Then they usually have a subheading to kind of get you more intrigued by it. And then usually if they're good, they have some images and graphics once you click on it to help convince you. So think a little bit about this and how your headline has to be intriguing and also communicate something about what your graphic is going to show. So if you remember one thing, this is the same slide as earlier. So write an executive summary and then summarize that executive summary into a sentence and create a graphic that illustrates that sentence. And that sentence you could turn into the question as well. And then make, during a presentation, I've seen this where a lot of people get into nuance before they get into the conclusion. Go to the conclusion first and say, you know, we think you should use a larger duct size because it will reduce energy use. Okay, you've said that. Now they'll, well, how does it reduce energy use using a larger duct size? Now you can get into all the details and nuances of, well, we assume this and that, and we weren't reducing static pressure, but you know, don't use the word static pressure in the initial statement because most people won't understand what that is. Use it later when you're explaining why the conclusion you came to is valid and true. All right, and with that, I am done. And there was a question. A little bit about specific tools used for some of the graphics. So I am proficient in InDesign, which is an Adobe product, and I use that for almost everything. You can control how graphics are shown. You can control colors. You can control text size. You can and the font you're using. You can do most of the same things in PowerPoint, at least at a decent level. So PowerPoint is probably the easiest one to use for most graphics. But if you have access to InDesign, I use it for everything, but that doesn't mean you can't use it. You can't use other software. Yeah, I use Excel for almost everything. Almost every bit of data I get goes into Excel somewhere so I can remember it. And then I usually export it into InDesign, and then I can play with fonts. But you can do the same thing in PowerPoint. You can export it to PowerPoint and then change the colors, change the fonts, and make it so it's readable top to bottom, left to right, bold to lighter text, etc.
Fantastic, Kjell. Thank you so much. I think it also makes sense not just for any technical reports, but anything generally, like anything that you're presenting externally. I recently started like my own Substack, and you can see how much time people spend on different sections, and you can tell like which ones get more attention because of XYZ reasons, and like you identified this tagline, line, and then a graphic that explains it, and you can actually see how people read through things. So this is amazing. We do have more questions. Do you just want to go through them? Do you want me to read them out?
You want to read them out?
Yeah, of course. So Ale is asking, do you have conversations with your consultants regarding what graphics you'd like them to deliver?
That's a good question. I think usually I know that I can interpret anything in an energy modeling report, and I have that sophistication, but we do, so I guess I don't do that. I should. We've put 209 into some of the things, but that's not about graphics. And there's not a single graphic in 209. Like really, I told the committee that I thought they should have more graphics in there. I think asking for graphics from an energy modeling consultant is great. You should do it. And when I get bad graphics from them, I usually do complain a bit. I say, well, what do you mean? What are you trying to do? Because then I have to recreate the graphic. And ideally, I wouldn't have to recreate the graphic to send them in. So I complain, but I should be more proactive, I guess. It's a good question.
But it's the same thing, like whenever we also in a similar position working within an architecture firm, we get a lot of these graphics, but then our team doesn't really want to show it to a client because they're so technical. And if our team doesn't understand it, you have to basically redraw the whole thing. So that's what I have to do as well.
Yeah. Yep.
What about your experience with harnessing AI engines to assist with any sort of graphic generation? Have you used anything in-house?
I haven't personally. I've used AI for certain things, usually writing, but I haven't used the graphic portion of it. Have you, Kritika?
So we did a competition for an urban redevelopment of a settlement in Copenhagen, and we did. I mean, this will raise a lot of questions, and it was like way back when AI was just booming up. So we used a lot of AI to do like data mining to come up with the keywords, what people were saying about that region, and then we used those keywords through Midjourney to generate some AI graphics. A lot of what we are seeing is our clients are telling us not to use AI to generate these graphics because you can really tell, and people are trying to move away from it. And then we have used some tools that use AI for simulation stuff, like predictions in very early stages, CFD related stuff, but that's as far as it goes.
Yeah, we've been limiting some AI use because when you use AI, you are giving somebody else a bunch of information, and
Right.
it could be traceable. You're giving this big machine a bunch of information which will digest and put into other things. And a lot of our projects that we're doing in like competitions or whatever are
Right.
confidential, or and so we don't want to use that.
Yeah. We just saw a client ask us to list all of the tools that we will use if we were to get selected. So this is like an RFP where they have a form telling us to be very informative of what is it that we are using. So they want to make sure that none of their data is being sent externally. So yeah, everyone is on the same boat. Going back to what you said previously, could you elaborate on what 209 is?
Yeah, 209, ASHRAE 209 is a standard that describes 11 cycles of energy modeling, 11 types of energy modeling, from early stuff to post-occupancy as-built energy modeling. I love that it requires the energy analyst to be present at sustainability charrettes. I find it interesting. One of the questions I ask is, do you know the name of your energy analyst? And if you don't, you are not coordinating, right? If you do not know that person's name, then you have not talked to them. As an architect, we know the name of our elevator consultant. And if we know the name of our elevator consultant, we certainly should know the name of our energy analyst, because it's a bit more critical from a performance standpoint.
Very rightly said. And then we have Kate asking, does LMN have in-house capabilities for analyzing building performance? Are you influencing your consultants' work typically?
Yeah, we do. So when I wrote my book, I was big on architects being energy analysts as at a kind of daylighting, shading, and using simplified tools like Cove Tool and Confin and what have you to do some basic analysis to get general directions of things. But I now work at a firm that does only large, complicated projects, or small, complicated projects, or medium-sized, complicated projects. But I don't feel that having an in-house energy analyst that is going to do like compliance modeling and tell us that changing the glazing percentage by 2% is going to save us this or that. I don't feel like we're the size of firm at 120 people that can support that person full time. We did have an awesome guy named Chris Savage work for us for a while, and he did energy analysis, and but it wasn't the compliance kind of energy analysis. And we just don't have the project types that are good for that. I think if we knocked out 20 office buildings in a year, we could probably have someone do that full time, and that'd be great. And they could, learn from each one. But when we do, convention center every 2 years, and we do, 2 office buildings in a year, it just doesn't have the scale to do that. So I think most architecture firms that are, a couple hundred people or more probably could do that and should do that. We've found, so we do stuff in-house. We have a climate studio, and we use that in-house. We use architect usable software for that, and I'm running it. If other people are running it, I QA their model, because we don't want to tell our clients incorrect things. We use C-Scale. We're testing out C-Scale right now for embodied carbon analysis. We've had subscriptions to a lot of tools like CoTool and Sapphira. We don't have any of those now. We use third-party energy analysts on almost every project, and that is the way that we do it. Other firms can do it other ways. What we found is we can get them on early. We can then talk to them, ask them questions, and they can answer most of our questions without any energy simulation. And between them and our mechanical consultants, we get the information we want when we want it. And so that's how we do it.
Right. And I think for us, similar in terms of the tools you mentioned, we often have people who can run at least a shoebox energy model, because it helps understand, let's say, winter to wall ratio or things that are not inherently clear. And then we also have people who would work across multiple geographies, so not just US, where if you're working in the same city for a while, you know the answers, so you don't need to run simulations. But sometimes we're like, let's just do it for the heck of it, and it's easy to convince a client to go for X versus Y. Yeah,
yep, definitely. If you work across many places across the world, and across even just the US, climate specific answers are very different.
Right.
It's humid, hot, cold, what have you.
Right. And we have a question on, are you and all models are wrong, but some are useful kind of person, or better to have some data than to have no data kind of person?
Ooh, okay. I'm definitely an all models are wrong, but some are useful person. The or is throwing me.
Yeah.
I'm interested in getting it just right enough to have a directional, if the question is, should we face the main entrance west or east, because we're gonna have a bunch of glass there. I think in most places it's gonna be east is better than west. And I don't need a model to run that, but if I was to have a model to run that, I'd have a more specific question, which is, peak load reduction or peak loads, or even system type. You might be able to have a different system type if you can reduce peak cooling loads to a certain amount. I'm a both and kind of person. I think it's any data I can get that I believe in is helpful in making decisions, but I will check the data, and then I will then present it probably in a different way than I got it in, to the design team, so that it's clear what the conclusions are and what's true and what's primary and what's secondarily true. So, but I love the quote. All models are wrong, and they are wrong. It doesn't matter if if you have 7 decimal places, if you're completely directionally wrong about the data.
Right. We also have a question in the chat that I'm also curious about. So when using graphics to communicate with a client, how do you convince them to choose the long-term design solution, which might be more expensive than the short-term solution? Do you have an example of that? And have you been successful in doing it? Because I am having such a hard time doing it in all of the projects I work on.
In other words, are the presentations successful at changing designs? Yes, very much. I think the biggest impediment to most of our clients is that energy is something they only peripherally understand. And when they understand something, they're usually going to make a good decision about it. But for some reason, people want to cost sustainability, whether they're not going to cost the granite countertops, or they're not going to cost the like nicer finish on the door, the same way that they would say, well, if we're doing that for sustainability, what's the payback on it? But generally, if people, you know, we did this, we were working with a university, and in a red state, and you know, we did this long exercise to see if electrification was the right option. We went through lots of cost models, and we over many months, and electrification was the right option. And we showed that, you know, we had matrices of this and that and the other thing, and we over time brought everybody to that conclusion. And it was through, you know, working through the data over and over and over. People don't want to make a decision based on the energy use and the HVAC system of a building based on, you know, something they don't understand. You know, if they're saying like, you know, chilled beams, all right, you did a presentation, the chilled beams are going to save me, you know, 7% of energy, which is going to save me $50,000 a year. You make that presentation, but they don't understand chilled beams at all. And they're like, well, why? This is, my facilities people tell me they don't work. And that's where we get most of the hangups, is then we have to go tour that facility. So you as the energy analyst that says, hey, chilled beams would be better. At some point, a tour needs to happen. The facilities need to be brought on board, say they don't, you know, they don't break, they're perfectly fine, and they're worth the extra investment. So thinking bigger picture about how, and I guess this is, you know, another, if you remember one thing, what is the decision you want them to make, and how can you help them get to that decision? The other thing is that architects make decisions about glazing percentage and orientation without a lot of client input most of the time. And so if you convince us to reduce glazing, we don't even have to take that to the client. So if you can show us a peak load graph and get the CFM reduction, which leads to a tonnage reduction, air handling unit size reduction, duct reduction size, you might not even have to go to the client. You can just convince us and we might do it. But I've rarely seen, I guess the other thing that we look for at LMN specifically is for our mechanical and our energy analysts to push on us a bit more than just say, well, here's the building design. Right. I ran an energy model on it.
And that's rare. I don't think I've had any recommendation come from the other side that often. Yeah.
That's like, well, we hire you to tell us stuff. If we hire an elevator consultant and they tell us you need more elevators, we will listen to them. If we hire an energy analyst and they just say, well, here's your energy model report, then, you know, with no recommendations, it's like, well, okay, that's not super useful. Why did I, you know, have you do that? But if you say, here's our recommendations for what we've seen on other projects for the most cost-effective savings you could get, and, you know, get you some more lead points or get you, you know, some more cost savings or something like that, yeah, that's what we want.
Yeah. Well, Kjell, as much as I would love to continue this conversation, I want to be cognizant of the time. We just have 1 minute left. So please join me in thanking Kjell so much. I've been through these slides before, but it was just so different hearing in from the person who actually invented these slides. So thank you so much for spending your Thursday afternoon with us. And I just want to flash this slide that says that we are starting up with our 2025 annual competition. We've confirmed the jury. We have Junko from Atelier and Jesse from Malum, who was also in one of the previous webinars, Kaylee Hood from Bureau Happel, and then we have Alpha from Northeastern. So all around a stellar jury panel. So if you want to follow us on LinkedIn, you can see the left image showing the name. So you can just type it in and you should be able to follow us. And you could also go visit our website and be in line for all of the webinars. So I want to thank you, Kjell, again, Neil, for sponsoring this webinar, and thank you everyone for joining us. Have a great rest of your day. Thanks so much.
Thanks, everybody. Bye.